Yeah, welcome back, my friends. Hey, my fellow YouTubers. I felt I owed a video to you guys. I feel like I owe myself a video. It's been a while. The last time you saw me, I was gleefully unwrapping my Modal Electronics 002, which I still think is one of the best synthesizers ever conceived of by the human race. And now you see me putting circuit boards on the desk. And not only am I putting circuit boards on the desk, but if you look closely, you'll see that what these circuit boards are, in fact, are modules to a modular synthesizer that I've been building for a long time. Now, why, you want to know, am I building a modular synthesizer rather than doing a demo for you guys on the wonders of the modal synthesizer and the rig I've got set up? Why am I not treating you to some sonic fare rather than going back to the drawing board on electronics? I got to tell you, it's because my Modal 002 is not here. It is not at the good old Owl House. The Modal Synth, in fact, is back in Indiana at the Sweetwater Sound location. Here's what happened. In a nutshell, Modal Synth can be upgraded online. You can get, they pride themselves on having online updates for their operating systems and whatnot. What I'm showing you here are a variety of boards that I will be using to build parts for my modular synthesizer in the future, just to give you some variety as I'm talking. At any rate, the modal synthesizer can be updated online, and I tried to update mine to their newest version of their OS and failed. Didn't work. Now, the support you get from Modal is greater in every way than any support I have ever received from any company on any product in the universe. You may say, well, that is as it should be given the price of the things. But what I'll tell you is this, that the support staff at Modal were on the case immediately. I got emails from them directly. And then, on top of the emails, I got a personalized Skype conversation with Paul Maddox himself. And Paul Maddox was able to log into my synth from Bristol, England, all the way out here to Los Gatos, California. And he logged into my synth, and he himself tried a manual upgrade using all of the incantations that he could do. I imagine he SSH'd into my machine, logged in remotely as root, did a whole bunch of things over the course of an hour. We had a really great conversation. I learned a lot about the company and the roots and the background. At the end of the session, my synth was bricked. Meaning it was black. It was dead, but I could actually run it, and I could program it through its internal web server. Actually, the synth has a web server, and once I get it back, I'll show that all to you. But it's non-functional. So I had to send it back to Sweetwater Sound in Indiana, and Modal is sending one of their troops. They're sending one of their guys. Right now, it's a Saturday afternoon in California. There's a man on a plane, presumably a British Air flight, heading to the U.S. He will be on Monday in Sweetwater Sound territory, Fort Wayne, Indiana. And he will be fixing my synthesizer, and I should be getting it back next week, at which point I will do a video for you about that. And we'll go through the whole thing. But that's just an indication, I guess, of a couple things. One is perhaps the maturity or lack of maturity of the Modal product, but B, the willingness of their people to stand behind the product to the point of getting on airplanes and flying across oceans. And I think that is amazing, because let me tell you, the synth is unique. It is worth it. It is, bar none, the best sounding synthesizer I have ever owned, and I have owned one of nearly everything.
That's the sound of the sequencer on the Modulus 002. I'm here with Paul Maddox, who is the sort of driving force behind the synthesizer, the mad scientist, shall we say.
I like mad scientist.
for you guys. I've built a bunch of these modules in the past, and let me put one of them together. And what I've got here is a, let's see if you can read, Synthesis Technology MOTM Class 300 Ultra VCO. Now, wow, once we start getting into modular synths, we got to talk about a lot of things here. We got to talk about MOTM versus Eurorack size. This is MOTM. It follows the old Moog synthesizer size of things. You'll notice the pots are pretty far apart. We'll put knobs on them, and you know, for my big fingers, that's fine. Eurorack is about 2/3 the size of this. You know, you could probably see that online. So I build MOTM scale just because I am a larger person. Let's see if that's in focus. Is that in focus? That's in focus. There we go. Focus. Right. I use MOTM because I'm a larger guy. I don't, as opposed to Eurorack. All of these, you can buy these modules pre-built with the panels on them and everything. I prefer to build them myself. It takes a lot longer, but at least I know what's in every one. This is, again, a Synthesis Technology MOTM 300. This is a voltage controlled oscillator, which has several outputs: sine, triangle, saw wave, and pulse. And you can modulate the pulse. You can sync them together to another oscillator. This one, you'll notice, has some board cruft on it. I don't know if you can see these wires. When I put this guy together, I had made some mistakes, and over the course of several years, this has sat in my garage, and every now and then I take it out and try to fix it, and so you'll notice all the official name for this mess is green wiring, but what I've done is where the traces have been broken, I've put wires myself. You can get the schematic. Paul has got those schematics online. He's a great guy. He'll talk to you. He doesn't sell the kits anymore. He sells the assembled parts because, frankly, these kits prove to be too much of a pain for him. However, you can get the boards, the naked boards, from Synth Cube. And in fact, I've got another board here for another MOTM Ultra VCO right here. Synthtech.com is his website, but he doesn't sell the kits. You can get the boards from Synth Cube. I'll put up the link there. And so you can see this is basically the same thing. I just haven't built this out yet. What else do we got here? I've got an LFO, Catgirl Synth, Psycho LFO, and that's one of Ken Stone's designs. And as you can see, this is kind of small board. And what I've got to do is I got to put these connectors on it, and then I've got to run these things out to some 1/4-inch cables. What else we got here? I just bought a bunch of boards from SynthCube because I was getting frustrated without my 002. This is a Thomas Henry design VCO 555. He's got a VCO built around a 555. One of the problems I've had with my synth building is I tend to gravitate towards just wanting to build all kinds of VCOs, and I don't have enough filters and things. So I'm going to have to, I've actually got a MOTM scale filter coming in that I have to build. This is another one of Ken Stone's designs. This is, when this comes together, it'll be a sub-oscillator. That's just the board. And this is a sequencer, Stro Modular. The guy goes online as J3RK, Jerk is his online name, and he's not a jerk. He's, the guy's a pretty clever designer. So this will be a modular synthesizer sequencer when I flesh it out and wire it all up. But this is how these things start. They start as boards that you pick up, and then you go online and you find the schematics and the part lists, and you go to mouser.com or DigiKey or whatever, and you buy all the parts. Let me see, I've got some others down here I could show you. Here's a board I put together some years ago, and I never actually used it for anything. This is a, what is this? This is a mini synth lab, sound lab. This is a Music from Outer Space was the guy's name online. He's actually ill right now, and he's not selling things online anymore, but this was one of his boards. This is a mini synth sound lab. It's a little self-contained synthesizer. You can put it's got connections for knobs and outputs, and it's like a little mini Moog replacement thing. As you can see, I put it together. I talked to him. This green wiring here is all stuff that we did. I did with his guidance. I put a sample and hold on it, and it's never been fleshed out. It's never been turned on. In fact, never got that anywhere. Down here, here's another thing I built some years ago. This is another Thomas Henry design. This is his percussion module, and it's all fleshed out and ready to go. And I just, there's a lot of I/O to this thing, and I just never bothered putting it together. I lost interest some time ago. I was putting these things together at a rapid rate, and then I started doing a lot of business travel, and I couldn't finish it. So I've got these boards that need to go somewhere. I've got some power supplies here. This is ready to be a 15-volt positive negative power supply. And basically, the MOTM boards that I built all use this power connector, this white connector here. And they take plus minus 15 and ground. So I use also 12-volt systems. I think most of the Eurorack, I think, is 12 volts. But that's easy to convert. And I've got another board over here that I'm going to use as a 15-volt to 12-volt converter so that I can run the 12-volt boards in my rack as well. And that's that. So that's the power supply stuff. Just to give you an indication, I tend to buy a lot of parts from Mouser and DigiKey. I buy them in volume. I never buy just one of anything. If I need here's an SN 7417 chip. I need it for some reason, and I bought 10 of them because buying 10 was actually cheaper than buying one and doing the shipping. So whenever I have to buy one of something, I tend to buy 10 or more and get the discount. Offsets the shipping. Here's some OPA 275 op amps, which are commonly used in a lot of these modular synth designs, as you will see. And all right, so let's. What I'll do is I'll bring you over to the modular synth, and we can take a look at how that thing looks. Okay, I haven't done many vids on the modular at all. It just sits here. I think in my opening welcome to the page, I take a quick picture of it and show that it exists. It's an MOTM style panels and boards. So here we have knobs that are, here's my hand, and they're about that big compared to my hand. They're 1/4-inch jacks instead of the tinier 1/8-inch jacks on the Eurorack. I've got here, if we just take an accounting, I got 2 Thomas Henry SN voice modules. This is a Paella MIDI to CV converter, so I can run MIDI through here and I'll get 1 volt per octave out and a gate, and I can run the rest of these things. Here are a couple of Ian Friends EGs, attack, sustain, delay modules. Here's another Ian Fritz module. I like his designs. I put a lot of them together over the years. Let's see. Keep this in focus. Yep, there's the 2 Ian Fritz. Here's a voltage control oscillator. There's an Ian Fritz jerkster, which is a really interesting device. If you're into the math of these things, it changes the control voltage based on the third derivative of the change of the frequency. I mean, it does some really wild stuff. You can actually simulate, very realistically simulate raindrops. I mean, it makes random stuff really cool. Here's one of Music from Outer Space's voltage control lamps. And down here we have a synthesis technology, sample and hold, and an Ian Fritz filter, and that's the only filter I have right now is this Ian Fritz right here. I got to get a 4-pole filter and a couple more things. And right here, here's a U-Synth saw animator. This is, you know, not a modulator, but well, it is a modulator, but it's a effects device. And then I've got another Thomas Henry filter right here, and here's the Synthesis Technology MOTM 300. So those boards that you saw in my little workshop basically go to a panel like this. Now what's going to happen is I don't have a panel like this, so what we're going to do is we're going to make a panel out of a piece of aluminum. We're going to cut the holes for it. And I'm going to powder coat it myself. I don't know if I'm going to be able to get these numbers in quite as nice as that, but that's what I did right here. So what this thing is, it's got no labels on it. This is a combination mixer. It's a 4-channel mixer, and then a CV multiplier. So it'll take the constant velocity control out of the paella up here, and it'll duplicate it so that I can use it on a whole bunch of these modules at once for programming. And then I can take the outputs of a bunch of those things and then sum them into a single output that comes here to the old microcube, which if you watch my videos I use for a lot of the sound generation stuff. Here's an example of a panel I made that's just bare metal. I have not powder coated this. That is a Music from Outer Space sine wave modulator. It actually modulates 2 sine waves and gives you some strange FM and AM effects. And that's how that works. Okay, take 2. So what we got here in front of us is a board by Kent Stone. Catgirl Synth is the name of his little company. It's the CGS 03, Catgirl Synth 03 version 1.0 Psycho LFO board. This is just the board. I don't have a panel for it. We'll have to make one. And I populated the board based on the schematic. Actually, the board tells you what part needs to go where. Here's some 560K resistors. Here's right over here is a little, I munged up, I didn't have a 220K resistor, but I had a 200K and a 20K, so I just put them in series and made 220. Made a note to myself to do an order from Mouser and get a real 220K. And now what I'm doing is I'm just putting these little MTA 100 connectors on there, and for no good reason other than putting them on there. What I'm going to eventually do is this is, as you can see, there, the 100K potentiometer goes there, called the Glide. I have a B100 linear, so it's not an analog. It's not an audio, rather. It's a B100 linear, 100K pot. And what we'll do is we'll put this little connector here, and then we'll build a connector wire that goes from there to here. And so this will get mounted on the front panel, thusly with this screw. It'll mount in and you'll turn it like that. And there'll be wires that connect from here to there. And this thing will sit on a metal plate, something like this. Here's a metal plate that's got some holes in it. And this is a real big one, but we'll put it on a much smaller metal plate. We'll mount it with some standoffs, and then we'll mount the metal plate onto the front panel. So there'll be a panel there, and this thing will happily sit on a panel in the modular synth, and we'll power it the 15 volts from here, positive 15, negative 15, 2 ground terminals. Here's the output that's going to go to a little jack, and I'll show you how we make all that. And hopefully one of these days my 002 will show up. Let's see if we can get this in here. Yes, my 002, my Modal Electronics 002, which is back at Sweetwater Sound, waiting for one of the Modal Electronics staff to show up there to teach them how to fix it. According to Paul Maddox, they needed to send somebody to do some training over to Sweetwater, so that's what they were going to do. I understand mine is the only synthesizer under evaluation at this point, so I guess they don't get sold very often. Put that somewhere where you can see it. There we we go. Pencil's just to hold. I'm just holding the, I got a pencil under there, just holding that jack up. And what I'm going to do is I'm just going to solder that one like that, and then we'll just take a look here and we'll see. See, as you can kind of see, it's not really flush. So what I'll do is I only have one pin soldered just slightly. So I'll warm it up and I'm going to press it on that side and get it in place. There we go. Actually, you got to be careful you don't want to burn your fingers off. But now you can see that it's sitting correctly, if you could focus it. But this is the field of focus of this little microscope camera is pretty small. So now we'll just solder on the rest of these pins. 1, 2, and that's that. So that's on there. I'll solder on the rest of these and okay, so next, you know, what you wind up doing with these things is there are many steps, and one step is getting the board. The next step is populating it with all the right parts. There's a debugging step in here where you power it up and we make sure everything's working, but we're not out that part yet. What we've done is I've connected all of these, put all these little MTA 100 connectors in here, and we've got the big MTA 156 for power here. And so now this board is fully populated as Ken Stone wanted us to populate it. Now what I like to do is I like to use these connectors because this way if I ever want to pull this board out of its little container where it lives, I'll be able to do that. So what I get is, see, you got these pointy things here, and then you buy the female end, which looks like this. And there's actually 2 versions of this. I like this particular version, and I'll show you how it works. There's another version that actually has all these metal grabbers, and you put the wire in and it grabs the wire directly. It's a little simpler. You don't need any special tools, but it doesn't work as good in my view. So the bottom line is what we want to do is we want to have wires connected to this thing, and then that will slide onto here like so, right? So we'll have one there, and then I have the one with the 3 prongs, which will go on that one. Right, so inevitably there'll be wires in here, and that's how they'll work. And they snap right in. You can buy these things off of Jameco. You just look for MTA, and things that the ones that are this size, they're 100 millimeters apart. And then there's the MTA 156, which is this one. You got to remember to buy the male ones with the prongs and the female ones that go, and they go by how many pin widths. So there's typically 2 or 3 or 4, and they go up to lots of pins. I have some, for instance, on a board down here, this Thomas Henry board, where you've got, you know, how many you got? 8, right? You got 8 pins here. So you get a connector with 8 pins. Now the next step is let's figure out how are we going to put some wires in here. And what are they going to look like? I am a strong believer that the wires should always look like what the connection is. So that means if it's a ground, it should always be green. If it's a negative DC, it should always be a black. If it's a positive DC, it should always be a red. And any other color should be whatever any other color you want. I mean, AC could be yellow or whatever. Signals inside the thing could be any color. So I'll show you, let's make a pin for this out. So this is the output of the board. And this pin on this side is ground. I can still see the D right there from the silk screen. And even if I look underneath, I can see how that pin is connected to the ground from the big MTA 156. So I know that the outside edge is ground. I want a green wire, and the inside edge is the output of this. I want some other color wire. I might use a blue one or a white one or something. So yeah, let's do that. So let's get a green wire, and I've got some green wire right here. Got a green wire. And I'll take some blue wire because, you know, blue and green, I don't know. And I don't exactly know how much I need because I don't know how this is going to get mounted yet. So I'm just going to arbitrarily pick kind of a couple inches worth here. And I'm going to snip it with my snippers. Kind of difficult to do this under the microscope because you got such a zoomed in view. All right, so I'm using snippers, these angle cutters, to cut the wire. And then I'm going to use wire strippers. Here's wire strippers. These are some very narrow gauge wire strippers. You see it goes all the way down to 30 gauge. I forget what gauge these particular ones are. They may be 22. Let's see what happens. All right, so can I get that in the screen? So I'm putting the wire in there. It's on the 22. I just pull the wire off and it comes out stripped, you see? And I strip off about that much, and I don't even know how much that much is. It's just that I've done this for so long and I feel like that's the right amount. And you can see I've got a red one, or rather a green one and a blue one. I apologize for the color challenged. The one on this side, there's green. It's the lighter one, I think, in your eyeballs, and the darker one is the blue. All right. Now what I'm going to do is I'm going to put on some of these end connectors, and you can get these in several formats. I like the ones that come loose in the bag. They also come kind of in a string tape form for automatic machines, and they look like this. All right. So now the challenge is I'm going to take those two connectors, and I'm going to get those connectors, and I'm going to connect those little connectors to the end of this wire. And now you can see why I snipped the wire as long as I did, because I want it to sit in this little metal container area right there, and just enough to have the, you're not seeing any of that, are you? Yeah. Let me get a tweezer. All right, so what we're going to do is, and you see there's like a little groove in there, and the wire is going to, just want the wire, get it in the picture, to sit in that little groove just about like that. So it makes contact, but I also want the insulation to be connected, to be held by that back part. Now, how am I going to do that? That seems like a challenge, and it is, unless you have one of these. This is one of these things, and it doesn't even have a brand name on it. It's probably something Chinese version of something, but what it is a ratchet-based crimper. And you can put many different dies into this crimper, and these are the dies for the, you can see the American wire gauge 24 to 30 and 18 to 22. So what we will do is we'll take these crimpers, and if you look at this die, you see that it's got, yeah, you can see the profile. There's a little indentation in here, right? So it's not just a U. There's actually, it's much more visible here. You can see there's a indentation there, and there's actually another one. There's actually another one right in there. So what we're going to do is we're going to take one of these bad boys, and we're going to station him inside this crimper so that his nose sits downward like that. Let me get this set. Man, I hope you can see that. All right, so you see what we've done? Here's one of these. This is one of those. And this nose part right here is facing downward in there. Now it's in the die. See him in there? And he's in this open hole spot right there. So it's just loosely in there. It hasn't been pressed that hard at all. He's just down that far. On the back side, we see that it makes an opening. And what we're going to do now is we're going to take our previously stripped wire, and I'm going to take this wire and I'm going to shove it into this hole down to the point where the insulation is also engaged. Kind of hard to see, kind of hard to do. And let's see, can you see? Yeah, all right. So the wire itself's in there, and the insulation is also being engaged now by the by the outer clamp. And now I'm just going to squeeze it. It's going to crimp it, squeeze it. You can see how it turned into a circle, sort of. And when I let it go, that's on there. Like magic, it's on there. All right, that's one. Okay, got that. So now what I'm going to do is I'm going to take the blue wire here, which has been stripped about that far. And you know, I suppose I could measure it. I got a measuring tape in here somewhere. Here we go. Let's see how far stripped it is. And apologize for all of you in metric land. This is looking like it's stripped, an eighth and a 3/16 of an inch, perhaps. Oh, let's see. This is 1, 2, 3. So this is an eighth. So it looks like about 3/16 of an inch. It's been stripped. And then we pop it in there so that the insulation engages, which we've got. You can see now we squeeze, which I am doing. We let her go, and voila. Now that guy as well is in there, and if you take a look, it's really kind of ingenious because the bare wire is being held very tightly by that crimp up there, and the insulation is held, and so this guy's not coming out. Now what we got to do is we just simply pop it into this guy. So as we said, what we want is the green wire to be on the outside. That's where the ground is and the output there. So I'm going to put the green wire into this thing on the outside edge, and what's going to happen is I'm going to slide it in there, and you see this little tang, this little bitty tang there? It's going to engage. It's going to engage, click, right there in that hole. And so now that ain't coming out. And now I'll take this one and shove it into there, the blue one, and we'll see little tang engaged. So now it's in. I could take it out by taking a little tiny screwdriver and pushing down those tangs and it'll pop out, but you see it's pretty secure. Now if I slide that onto here, we've got connection. So I have a ground wire and an output wire connected to that MTA, and that's pretty solid. I have to kind of yank it to get it off. And let's see if we look down there, you can maybe, if I could get it into focus, you can sort of see the metal slats are sliding upward and back. So when it goes on, it very positively engages those two things. So that's how we make a connector for the Psycho LFO. I'll make the other ones, and then we'll see if we can get around to testing. All right, so now we've got I've got these things built. And what I'm going to do now is try to solder these wires. I've got one made already, so I've got one onto this this 1 meg pot, and that had nice little round holes that I could connect things to. These do not. So what I will do is show you how a person like me might consider to attempt to solder something. I mean, theoretically, these things want to be on a circuit board, right? You want to plug these into a circuit board. That's the easiest thing to do, and then you can put the wires on them. But for the sake of this particular demonstration, what I am going to do is just solder directly to those pins. So as you see, I've tinned the pin, put a little solder on it, and then I'm just going to warm it up. And if the gods of solder are on my side, that will just stick there. Now that's not such a great connection, I know, and that's not where I'm going to leave it permanently, but for the sake of being able to demo to you folks, that'll work for now. And if I was going to leave that there for real, I would put a piece of heat shrink tubing on it, and oops, things are falling. I'd put a piece of heat shrink on it so it didn't short to anybody else, but I'm not going to leave it that way. I'm just going to put it that way from now. So now let's get back there. And this always feels a bit like some weird form of surgery when I do these things. You got, your fingers wind up all twisted up in different angles and stuff. But as long as you tin the pins first, because what you're doing is you're not having to apply solder, it's already on there, right? Solder is already on there, so all I'm doing now is just positioning things using my fingers as the ultimate positioning guide. Thank God for opposable thumbs. If we were dolphins, we would never be able to do this. Okay, there you go. So, kind of messy looking. I got some stray wires here, you know, but that one actually came off. Here, let's do that one a little better. Put a little more solder on this pin. Now, you know, for reasons I don't entirely understand, you should never solder into these holes. I don't know why you're not supposed to do it. I just know that, generally speaking, every electronic tech I've ever talked to in the world has said, oh God, don't solder into those holes. So I don't. It seems like you might want to, given how hard it is, just to tack solder to a flat thing like that. But you don't want to do that. All right, so there's one. So that's on there, and on the other side is that. See, I've got these. Yes, if I get it into the picture. Wow, this is a microscope, isn't it? All right, so I got that there and that there. And I've got one more to do. I've got to solder the ends here. I've got that one. Hey, so what happened here? Okay, so I got this all powered up. Everything is connected and in there, and I've got the potentiometers. Well, man, really hard to see there, but I've got the oscilloscope hooked up. I was going to put the wide-angle camera lens on so you could see the thing oscillating. And instead of oscillation, I got the magic smoke out of this. Let's take a look at what this is. This is an SN74HC14N, HC14N, 74HC14N. What does Ken Stone say should be the chip there? The chip there, according to Ken Stone, should be a 74C14 or a 4106 or similar. I mistakenly thought that this bad boy was similar because it had a 74 and a C in it afterwards. But of course, it's got all those other numbers and letters. And when we go and look up the data sheet for that, at Texas Instruments, this being a Texas Instruments part, see, there's the little Texas Instruments, state of Texas with an I in it. I go look at their part, and it says the maximum supply voltage to this bad boy is 7 volts. What have I been applying here? Right here, VE. I have been applying plus 15 and minus 15. No matter how you look at it, I'm over twice what this guy wants to see. Well, oh well, oh well. That's part of the joy of putting together your own modular synthesizer is sourcing the right parts. I got to find a 74C14 or a 40106 somewhere. And, you know, a lot of these things have been designed some time ago. These guys designed these things, and the parts that they used are now obsolete, so I got to go find a replacement. So that's part of what I got to do here. In any case, you can see the joy of modular synthesizer development, just for grins, just so we don't leave a failure. I think what I'll do is I'll show you, let me show you the Synthesis Technologies Ultra VCO chooching away quite nicely, because it does work. Okay, so there's the here's the MOTM VCO 300 sitting there. It's all hooked up, and here's the oscilloscope trace, and we're getting a nice sine wave out of that. And if we turn some of these knobs here, you see I can change the frequency. It's working quite nicely. Here's the sine. Okay, let's be careful about this. There's a triangle. There's a saw, looking quite sawy, pretty good. That's a sync signal. Here's the pulse, square wave. So you can see this one's working pretty decently. It only took me 4 or 5 days of continuous work to get that to go, but now she goes good. So the next step is to we'll remove her from all of these surgical accoutrements. We're going to put her onto let's get this focused. I'm going to put her onto this board here, onto this mounter in there. And then that'll go in a panel and slide in to the modular synth. Okay, that's what we're working on now. I'll get that little LFO, the right part, and we'll get cranking on something new. And maybe the 002 will show up soon as well. All right, hey, thanks for watching. I really appreciate it. Thanks for your time. Thanks for your patronage. Drop me a note. Give me a thumbs up if you like the work we're doing. And thank you very much, guys. Talk to you later.